The next example for the discussion is determine the function whose first order forward difference is x cube plus 3x square plus 5x plus 12. This is a bit different kind of example, therefore we mark star over here. Determine the function whose first order forward difference is this. Now I have been asked to write down or obtain the original function whose first order forward difference is this. Now one question can be arised in the mind that if this is the first order forward difference, then why it is not in the factorial notation? Because here first order forward difference is written in the factorial notation, but यहाँ पर तो नहीं दिख रहा है. बट मैंने बोला था कि ये जो भी नोटेशंस होते हैं that can be converted to the simpler form. So though this is the first order forward difference, it has been simplified by applying the definition of factorial polynomial. अभी जब मुझे ओरिजिनल फंक्शन निकालना है, मुझे रिवर्स प्रोसेस अप्लाई करना पड़ेगा. What is the reverse process of the derivative delta? Anti-derivative, anti-difference. If delta is the forward difference operator, 1 by delta is the inverse or anti-difference operator, which will give you the original given function. Right? जैसे डेरिवेटिव को हटाने के लिए इंटीग्रेशन लिया जाता है, मुझे वैसे ही यहाँ पर 1 by delta ऑपरेट करना पड़ेगा to remove this derivative and get the answer as the original given function. But delta, 1 by delta are applied only to those terms which are in the factorial form. Here, though this is delta f of x, it is not in the factorial form. इसको फैक्टोरियल नोटेशन में कन्वर्ट करने के लिए आई विल हैव टू फर्स्ट अप्लाई सिंथेटिक डिवीजन एंड देन टेक द ऑपरेटर और ऑपरेट द ऑपरेटर 1 by delta. So let f of x be the required function. This is first order forward difference. So delta f of x will be x cube plus 3x square plus 5x plus 12. Since 1 by delta is integration in the factorial notation, we first express delta f of x in factorial notation by method of synthetic division. What are the coefficients? 1, 3, 5, 12. So dividing by the factor 0 is immaterial. Last term, which is the remainder, is constant or coefficient of x to the power 0. Remaining terms are 1, 3, 5. 1 as it is. 1 into 1 is 1. 3 plus 1 is 4. 4 into 1 is 4, 5 plus 4 is 9. 9 is the remainder, the last term, which is cut off from the given coefficients and is treated as coefficient of x to the power 1 factorial. 1 and 4 are left, next factor is 2, 1 as it is, 2 ones are 2, 4 plus 2 is 6. This is coefficient of x to the power 2 factorial. Last factor is 3, but not to be considered because 1 will remain as it is. There is no point in performing the division. So accordingly, what is the coefficient of the highest degree? Coefficient of the highest degree is 1 and highest degree of the factorial polynomial is x to the power 3 factorial. Now expressing it in the reverse way, 12 into x to the power 0 plus 9 into x to the power 1 plus 6 into x to the power 2, 1 into x to the power 3. That is how we will be writing down. 1 into x to the power 3, 6 into x to the power 2, 9 into x to the power 1, 14 into x to the power 0 factorial. This is your delta x from the given plane polynomial, the factorial notation. Now to remove this delta, I have to take the inverse operator. What is inverse operator for this f of x? 1 by delta. 1 by delta to be operated on this particular factorial polynomial notation. Now 1 by delta is integration. Integration increases the power. So what will be the integration of x to the power 3 factorial? X to the power 4 factorial by 4. X to the power 2 factorial ka integration, x to the power 3 factorial by 3. 6 by 3 is reduced to 2. 9 as it is x to the power 1 factorial ka integration x to the power 2 factorial by 2. Constant is 12. 12 into integration of dx is x, but x is written as x to the power 1 factorial. And in integration, constant of integration is written as c, where c is constant. Now take common LCM or the denominator as 4. Simplify it. X to the power 4 factorial will be written as x into x minus 1 into x minus 2 into x minus 3. X to the power 3 factorial will be written as x into x minus 1 into x minus 2. X to the power 2 factorial is written as x into x minus 1. X to the power 1 factorial is written as x. So accordingly, by definition of factorial polynomial, we will be having this particular step. Try to simplify. This will give you x to the power 4 as the term. Accordingly, simplify each product, collect the like terms together. You will be having the final answer as 1 by 4 into x to the power 4 plus 2x cube plus 5x square plus 40x plus 4c. That is how we try to simplify and get the original given function. This is original given function whose first order forward difference is this. Try to check whether derivative of x to the power 4 is 4x cube, 6x square, right? 3 2s are 6, x square, 10x, and accordingly this will be the first order derivative for the given original function. Divide by the appropriate term, you will be getting the simplified form. Constant can be adjusted anytime, anywhere. So this is one bit different kind of example or the problem where we have come across with the integration or antidifference. This example is not to be considered as it is involving the forward difference operator table, which is not in our purview. The next and the last example related to this is express f of x is equal to x cube minus x plus 1 in factorial polynomial and also obtain antidifference of f of x. Antidifference means inverse operator of delta, and which is nothing but 1 by delta. So directly here we are asked to find out the integration for whatever factorial polynomial we will be generating for the given function. So given function f of x is x cube minus x plus 1. Express it into the standard form, perform the synthetic division, and then we calculate the antidifference. So let f of x is equal to y, which is x cube minus x plus 1, but it is written as x cube plus 0x square minus x plus 1 in the standard form. What are the coefficients? 1, 0, minus 1, 1. This is the coefficient. I have not divided by 0. So the remainder or the last term is nothing but constant or the coefficient of x to the power 0 factorial. Divide by the factor 1. 1 remains as it is. 1 ones are 1. 0 plus 1 is 1. 1 ones are 1. Minus 1 plus 1 is 0. The remainder to be cut off is coefficient of x to the power 1 factorial. Remaining coefficients are 1 and 1. 1 as it is. Other factor is 2. 2 ones are 2. 2 plus 1 is 3. 3 is coefficient of x to the power 2 factorial. No point in doing further division by the factor 3. This number will be carried forward as it is. 1 as it is, which is coefficient of the highest degree, that is x to the power 3 factorial. Writing it in the reverse way, you get x to the power 1 into x to the power 0 factorial, 0 into x to the power 1 factorial, 3 into x to the power 2 factorial, 1 into x to the power 3 factorial. So that is how the function f of x is x to the power 3 factorial plus 3x to the power 2 factorial plus 1, which is the factorial notation for the given original plain simple polynomial. Antidifference of f of x is nothing but calculation of the derivative, reverse process of derivative, that is integration. 1 by delta of f of x, 1 by delta to be operated on this. X to the power 3 factorial is x to the power 4 factorial by 4. x to the power 2 factorial's integration is x to the power 3 factorial by 3. Constant can be written as x to the power 1 factorial by 1 plus c, which is constant of integration. And if you wish to, you can apply the definition of factorial notation and express this as x into x minus 1 into x minus 2 into x minus 3. Else, keep it as it is. It depends on the options what are provided. X to the power 3 factorial will be x into x minus 1 into x minus 2. So this is how we try to find out and simplify. If not, keep this as the final answer, because they have asked just you the antidifference of f of x for the factorial polynomial. So keeping the answer as it is, you can finalize it, or if it is not matching with any of the option, you can go ahead with